Well, thanks everyone for taking some time out of your busy week to join us here, engage with the RChain Cooperative. Always appreciate your engagement. We have a couple of demos, if I understand correctly. So we should probably go ahead and get underway. Rao, are you ready for the tech update?
Yes, I am. Okay, so I think you should be able to see my screen now. Let me see who is here, because we have two presentations. So Nutzipper is here. I see that. Is Raphael here? He was also going to do a demo later. Okay, let me get started with the tech update, and then I'll turn it over to Nutzipper for his demo. So we are continuing work on finalization. Thomas Lowe realized as he was working on finalization this last week that he has to do some work on the block retriever, and he has nearly completed that. So he's now completing the block processing and cleaning up that task, and whatever tests are needed for that, and is moving back to doing the main work on finalization that he's been working on. That this came as a piece of that needed to be fixed. He has already done much of the code on finalization. So what he has to do now is take all these pieces that he's been working on and integrate them and do more testing. And then it'll be ready for Nutzipper to do his piece on merging of the state. So when all of these pieces are completed, basically we'll have the finalization code ready for deployment to the testnet. You can look at the current PRs and what's going on in there, but I'll speak to what the other folks are working on. Will was working on the registry update as a soft fork for the last few weeks. And Max was helping him with some portions of that. That task is now fairly complete. Will and Max have been writing tests on that. And other than that, the coding piece there is complete. So Will also has been working on calculation for random seed as a new thing that does not include timestamp, because timestamp is not reliable. And that task is, or the code for that is also complete, and they're writing tests on that also. So that's what's going on with Will and Max by and large. After the cleanup on this and completing, making sure that the tests are working and everything, Will is going to move on to the next task, which is the bonding process for external validators. That's described in this issue 3714. So he has to create that, and that process of bonding of external validators also will be used as a test case to test the registry update process that was just created, that was just completed. I mean, there are other tests that were also have been done for the registry update. But this bonding of external validators would be like a live test of that. So that's what's going on there. There is quite a bit of work going on in terms of getting the external validators ready. Gurinder is setting up a testnet where more than 51% of the nodes and stake will be run by non-co-op, by validators that are not the co-op. And I think we have so far informal commitments by about 8 parties to run nodes for the RChain mainnet. So a good number of them are either already familiar with how to run nodes on the RChain network, or the new ones, they are gaining experience running the nodes. They have already run, all of them have run observer nodes. They're now starting to run validator nodes, and then they will be gaining experience reading the logs, trying to monitor their nodes to make sure everything is up and running. And then if there are any issues, to be able to use the logs to be able to troubleshoot or figure out what's going on. They will also be going through version updates because that's something expected as part of regular business when they're running nodes. They'll be going through epoch changes and other steps. So these are all things that they would normally encounter when they're running the validator nodes. So these are all the steps we want to walk them through at least a few times before we say, okay, you're now ready and equipped to run a validator node on your own smoothly. So that's the activity that's going on with them, and that'll probably continue all or most of June. Meanwhile, on the business side, the co-op will be creating the service level agreements that these validators have to agree to. And Ian is creating the KYC process for the validators because we want to make sure that the network is being operated by people that pass regulatory muster and that we have a KYC process to support that. Additionally, the board and the membership have to work through the process to get the necessary IOBs for external validators. So we're getting the IOB ready for voting by the broader membership. So those are all different activities going on with external validators. Stas has been working on enhancing property-based testing. I'm not sure if, let me just give a brief description of what that is and why it is important. I put some links in here if you want to read up a little bit more about that. So basically what property-based testing, it's also called law-based testing. What it is it helps developers quickly write tests based on specifying a bunch of laws or properties or constraints, if you would, rather than trying to think up of all different it's not about, okay, like let me do this range of testing and that range of testing and hope that it holds. Instead, you're able to define a broader law or constraint or property that the behavior of the code is supposed to satisfy. And then that way you basically get more coverage and they're quicker to write. And there are features from the packages that we use with those that identify the smallest test cases that are failing. And that's important because if you want to debug, you want to be able to say, okay, what is the smallest test case that's failing, because it gives you a little bit more insight into really what the core problem is. And so that enables faster debugging. All of this is important when we go to external validators and have a fully decentralized network. Because we expect a much broader variability in the network conditions, in the hardware conditions. And of course, there's always the potential mischief in a decentralized network, which we're not expecting in the first round of validators that we're working with, because it's still considered a sort of a friends and family type of an approach to external validators at the moment. But we want to be prepared for a case where the network may be down, and coordinating all these external validators to apply the fixes and get the network back up is a very important thing that we have to run through. So these tests and this faster debugging that's enabled by these tests, they help us prepare in that direction. So that's the relationship between going to a decentralized network and then having a proper or faster testing and debugging methodology so that we can respond to issues much faster. So that's how they're related. Please do read through those links if you're interested. It's a very interesting thing, and they talk about the tools within Scala that we're using: Scala test, Scala check, and Scalactic. Those are the ones, and I think Stas has updated those libraries to some intermediate version now. he still has to do update to the latest version and then finish up whatever he's doing there with the test. And then the next step then is for all the developers to be able to use that feature for tests in and it helps them write tests faster and incrementally and also run them incrementally. So that should help everybody out in that process. The other piece, Dennis has been working on implementing the BigInt type based on community feedback. So as he was doing that, he got the basic implementation for BigInt done, and then he was looking at how should it be costed. So in that process, he went into a deeper dive on cost accounting to basically summarize how we are currently doing cost accounting for all different operations, not just the BigInt. So that's a very, very useful exercise from a documentation perspective. At the moment, he put it on the RChain secure repository so that the team can look at it and then resolve anything that may be problematic, but we will eventually probably publish out to the broader network those findings. Basically cost accounting is one way you use to prevent DDoS accounts, denial of service accounts, distributed denial of service accounts in the blockchain world. And so if we are giving away any resources or computations for free without limit, those could be potential attack vectors. So this is the reason why the team is looking at that, looking at all of that. So far we did not see anything problematic as of now, but it's good that Dennis is going into all of this and then trying to say, okay, now this is what we're doing with other operations. What should we be doing with the operations for BigInt? Because BigInt can be computationally intensive just because it opens up a much bigger integer and much bigger storage type of implications on there, much bigger computational burden potentially. So he's documenting that, and that's very useful to use in his completing the cost accounting plan for the BigInt type. And this is something also people need to be aware that anytime we introduce new types in Rolang, we need to look at, okay, what do we need to do cost accounting wise for that? So that's what he's working on. And Nutzipper has been continuing to work on and he'll actually demonstrate his work today, so I won't say too much about what it is, but he's been working on generating Rolang deploys in Scala based on RabbitMQ topics, both on the input side and on the output side. So basically take it in on the input side from RabbitMQ and then publish back to RabbitMQ on the output side. So that acts as the gateway for integration with all external systems. So he's going to be saying more about that, I think. But before I turn over to Nutzipper, are there any questions or comments on anything that I shared?
I think you wanted to say DDoS attacks and not accounts. You said accounts.
Oh, yeah, so thank you, Raphael. Yeah, DDoS attacks. If you have problems in cost accounting, there could be sources of DDoS attacks. So that was, yeah, I guess using accounts and attacks in the same word. I must have messed up. Thank you for pointing out. All right, over to you, Anton. You ready for demo?
Yeah, sure. Hello, everyone. I already shown the pieces on one of the previous debriefs. Now I just want to expand on that and show the current state and with a bit of more color. So let me share. So I think you should see my screen, right?
Yes.
Okay, cool. So this is the RabbitMQ installed on the server next to the R node. It has a nice interface. Now we can see that there are no queues. So the middleware that I'm developing will create queues on a start. So we have a node or a fresh node. We just minted the genesis, and we have a jar file. So it's just a Uber jar which contains, and you can just run it on the Java and it will do its work. So let's start it and observe the output. What it does, it checks the chain. If it doesn't see the contract deployed and available on the chain, it will deploy one. So this is what it does. After the deployment, you can see that there are a bunch of inputs, output, and tags for input. So these are unforgeable names which you later can use for the get data at name or get data at par API of the node. So that's it. Soon these will start producing. Yeah, you can see that queues are created here. And now you can see that on the Rabbit ports, data is sent, and middleware receive them on the ports and translate them into deploys and send on chain. After being executed, this contract performs the transformation of inputs into a bunch of inputs into a single output. This particular version of the contract just concatenates the strings. So here you can see that some strings are sent onto the channels. There are 7 channels from A to G. And now we can observe what's there in the output. Let's check. We can see that now one ready, now 2 next result has been created. And if we will wait a bit, we will see this number increasing. This means that the middleware listening on the output channel on chain, once new result is available, it pulls this result through the get data at par API and pushes to the Rabbit queue. So anyone can just who's using this middleware or this program, he can listen to this queue and get this data back. And let's just take a look what's in the queue. Here you can see some really long string. It's just a random string. So it's a concatenation of 8 different strings. But you can, and what we are going to do, you can parse these strings in some data structures, and you can make some operations with these data structures. So reduce them into a single output. And I just want to show how it's done, like how this can be extended. My findings, how I did that. So what you have is a single object with the bunch of fields. You have the term, which is the main contract. This main contract creates 7 unforgeable names, output name, all the necessary names to ensure the logic of the contract. And this is the main logic. Listening on all 7 names, once all of them received, do some transformation, which is concatenation, and placing that on the result name. I'm not going to go into details on this particular way, how exactly the result name is created. And that's it. And then basically what should be done on the receival of the input is the middleware creates a deploy, fills the data, fills the name according to the input queue of the Rabbit, and sends deploy into the chain. So, and then you also have the encoder, which tells you how exactly you should encode and decode your data. And that's it. So this will be later extended to more complex reducing of the input data. So this is it. Okay, now there are seven results. computed for now. So this is it. Thank you. If anyone have some questions, feel free to ask.
Well, so thank you very much, Anton. That was great. I really appreciate it. I do want to make some comments for people who are listening or might be listening later. Basically, what this makes the chain into is a far superior workflow engine than is currently in the market. So it eclipses the features and functions of Microsoft's BizTalk, for example, and many other products in the market. You can also now use this as a basis for the same sorts of things that the data mapping services like Talent do. And this was where we are currently is roughly 3 weeks of work to create something that is superior in features and functions to the existing workflow engines. So people, I don't know how to emphasize how much functionality is available in the existing chain. It's you know, like, think about it: RGov, RChat, the payments network that it also provides, as well as workflow engines and data mapping services, right? That we are now demonstrating as features and functions. It's really quite a remarkable platform that we have here, and I do hope people can understand what they've got. All right, any other questions for Anton?
I just want to say that, like, the first week I spent trying to just run the Scala client. So this is what we have in not very good shape. It's just hard to bootstrap a client in Scala. So you need lots of stuff from the node, and you need some knowledge about the whole process. So once we will make these fast and easy, it would be much faster workflow.
Yep, agreed. And taking on tasks like this is part of what, you know, makes that evident to us, and we can make the integration pieces smoother and easier. Yeah. But also with the Rabbit APIs now, a lot of enterprises won't even ever have to deal with the Scala client, right? They would only have to deal with the Scala client if they wanted to do something special. They can just deposit stuff into Rabbit, and that will give them the ability to do deployments to chain. So this is super important, and to anyone who knows anything about systems integration in the enterprise, this is very, very exciting. All right, thank you so much. Raul, did you say that there was another demo?
Yeah, Raphael wanted to do a demo. Raphael, you want to take it from here?
Yes, hello. Yes, I'll share my screen. So I'll try to keep it under 10 minutes. So I'll put this on the left. So yeah, so first of all, I'm Raphael. I'm a member of the RChain co-op, as well as the lead developer of the dappy project. So today we'll mainly talk about, so this presentation is a follow-up from like few weeks ago presentation where I presented the multisig with the command line tools, and now I'm presenting the UX that has been built on dappy browser. First of all, thanks to the so this is teamwork, of course. So there is myself, Bill, David, Patrick, Theo, and Pratyush, who have all participated to the developments and discussions around multisig. And we'll be using dappy as well. So this is a preview of the new website. So dappy is a web browser that allows you to like distribute websites in a very secured way, and it has a cool feature which is called dapps, and dapps are basically HTML files stored on the blockchain, so you can have truly serverless web applications. And what we will see today is the multisig UX distributed through a dapp. So you can check the multisig code on GitHub, RChain multisig. Last week we had a session where we played with the multisig, so we were not many, but everything that I will show today, you can do it with dappy browser. Dappy browser has been released 9 days ago, so you can just download the last release. And I think I'm ready to go into it. So just some context taken from like 3 weeks ago, the first presentation. So multisig on RChain are seed-based, and they are not public key-based or token-based, which means that the membership can evolve over time. You can have 2 persons at day 1 and 1,000 at day 2. And you can also, of course, vote to kick members. So you can go back to 200, etc. And every decision that is taken is based on a 67% threshold. And when this threshold is reached, which means that 67% of the people have agreed on the exact same set of operations, then they are executed. And on the right, you can see some example of operations that you can propose in a multisig. And one last thing, so yeah, just for the ones that are not familiar, so dappy is a web browser, and RChain is the blockchain platform that powers the name system that is part of dappy, as well as the multisig that you will see. So I think that's it for the context. So now I'm switching to dappy browser. This week's session was on the testnet, but today we'll work with a local network, so it's even faster. So the first step, if you go to multisig.dappy, you can either load a multisig that you know about or deploy a new one. So we will start with this first step of deploying. So I'm inputting my password to decrypt my private key. Okay, I'm wrong again. And this is similar to MetaMask. The web application is not responsible for manipulating private keys. So I'll just send my transaction to deploy a brand new multisig. And it will also instantly, I will instantly apply into this multisig and be accepted because when it's deployed, it's empty. And the first person who applies becomes the owner of a multisig. So that's great. We have the address here. Now I can probably load it. And this is so I'll go on full screen. So this is the main page of, it's kind of the dashboard of the multisig. So I will not go into every section, but what you can instantly see is that it has a rev address. So multisig can, of course, manage funds. It has a list of members, and you can like click on those actions if you want to propose some stuff. So now I'm going to switch to my command line because we're going to do some very interesting stuff and work with a big set of members to demonstrate how it scales to dozens of users and even thousands. So the first step is so I have built some small scripts very quickly. So I need first to set, okay, I think it's okay. So now I can do node CLI and apply 50. And what this will do is execute this script, of course. So we'll have those 50% that apply to the multisig. Let's do this. Let's check the logs. of my R node. Everything seems to be great. Okay, so we have all the applications registered. And now Bob, which is on the web page, can just reload and wait for the applications. They are here. We can see submitted applications 50. So I'm still the master of the multisig. I have accepted no one. So I could do one by one or just choose Ashia and Aiden, but I don't want to do that. What I'll do is use a script to go very much faster. So this is the second script, node CLI, accept 50. So what I will do in this script is very simple. I will iterate over every member and add this operation to the list of the operations I'm going to propose. Let's do that. Okay, so I have forgotten. So I'm proposing as Bob, of course, because Bob is the only member right now. Okay, and you can see the batch of operations that will be instantly accepted because Bob is the only member. So he represents 100%. Okay, second log. That's great. So what we can do, waiting for, it should be already, okay. I'm going to move a bit. So I'm going to go to accounts and send money from my account to the multisig. This way we can anticipate on the next step. Okay, I want to send to this address and let's say 3 revs. Let's go. Okay, that's it. Back to full screen. Okay, back to this section. So now I'm going to reload again to see what's new. What's going on. Okay, and now we can see that we have the 51 members in the multisig. So I'm not at all the master of the multisig anymore. It is now controlled by 51 persons. So that's cool. Let's reload again to see if the rev have landed. Okay, nice. So we have the revs. So now this balance is under control by many people. That's exactly what we want. This is very, very secure because we need agreement from many people to do some stuff with those 3 revs, to move them basically. So now next step, I'm going to show the proposal system. So first, what we'll have is not 30, but like 25 or 26% proposing a rev transfer. So let's do this. So it's propose A. That's it. So you can see all the roll-long terms. So I'm kind of cheating in this demo because I'm using the same private key for everything. So you can see all the deploys that have been concatenated. And this may take a bit of time. Okay, you can see everything. So each time a proposal is accepted, the smart contract checks if agreement is reached or not. So that's why it's it could be faster, but it checks each time. So I think we are almost okay. Going back to the browser. Reload. Okay, and you can see that each time it logs operations recorded but did not execute, because as we will see, we have not reached the 67% threshold. So this section tells you who is proposing what at a given time. And we can see that there is this proposal that is proposed by those people. and I think they are 25, so we can check what they want to do with the money, and they want to do that. But it's simply pending right now because this is below the 67% barrier. And this number is a random number that is generated based on the operations. And this allows you to safely refer to a proposal. Because if you say proposal, you chat with some friends, you say, hey, I like proposal 1 or 2. If some other proposal come, it could add confusion about which one you were referring to. So now we're going to have the second step of people proposing something. So it's propose B, and A is, so this is the proposal A. It's a single operation. And B is a ref transfer as well, but to another address. So of course, there is this disagreement, so nothing will be executed. So let's get back to the logs. Nice. Let's reload again. Okay. Maybe a few seconds. Okay, so there we go. Now we have this second proposal, 1889. Of course, different members are part of this proposal, and none of them has reached the 67% limit. So this is the end of today's demo. We could have demonstrated kick out as well. So you can vote to kick a user if you want to. And a last thing, so to give some context, so multisig are very well known to be a kind of cryptocurrency protection mechanism where you have many of your friends who are responsible for your Ethereum or Rev or any cryptocurrency with you. So that's great, but in the context of dappy, it's also very much important because there are some very good critiques about name systems on the blockchain. And the main one is that if Nike got its private key stolen, if the person responsible for Nike in the dappy name system loses its private key, then it's not a good situation. So in the case of dappy, when we'll have big companies coming at us, and even small companies, and any company or any person, we will very much push for them setting up a multisig to handle the NFTs. And dappy names are NFTs. So for example, this is a NFT, and it can be controlled as well by the multisig that you see on the screen. So this way, we have a secure name system on the blockchain, but we have avoided the main concern, which is the issue with people losing their private key or people being hacked and private key stolen. So yeah, that was a kind of contextual thing regarding dappy, but we can't see those NFT management capabilities yet in this demo, and they are not developed yet. So that's it. Again, thanks very much to people who have worked on this, Bill, David, Patrick, Theo, and Pratyush. And yeah, maybe next time we'll have different things to show. Thanks.
Thank you, Raphael. Great demo. Any questions for Raph?
That's very nice. Thanks, Raphael.
So Raphael, I have a couple of questions. One is, do you think you could build a dappy component for signing RChain transactions? So it could be just like, either what you were calling an HTML on chain app that any app or user could use just to sign an RChain transaction. Is that something that could be done?
So maybe I'm not getting it, but if you are referring to creating a RChain transaction based on agreement between users, I don't see how it's possible today. But yeah, any HTML file that you put on RChain and distribute through dappy, you can call some browser APIs to pop this window to sign transaction.
Okay, I see.
Yeah.
Yeah, I mean, basically what I was thinking about was replacing that MetaMask feature with something that's more native to the RChain ecosystem.
Yeah, I think we need both a dedicated browser extension for RChain and of course the integrated stuff in dappy as well.
Okay, yeah, that makes sense. My other question is, why 67%? Why not make it programmable or configurable?
Yes, it is. So you can change it over time if people want to have like 50 or 90.
I see. Okay, so it is actually programmable.
Yep.
Okay, cool. Awesome. Thank you very much. Daryl, did you want to do the week in review?
Yeah, sure.
Okay.
Yeah, that's super exciting, Raphael. It's incredible, how much work you're doing these days. Same with you, Nutzipper. Really amazing stuff going on. So anyways, here's the week in review for Thursday, May 26th to today, Wednesday, June 1st. Last Friday in the Climate Coordination RCast, Lilia Russo from the RChain staff and her friend visual artist Shraddha Boraki joined us on the call. We discussed a former Shell consultant who quit, a new finance report focused on climate from Deloitte, and a recent blockchain news, as well as Shraddha's most recent work. On Monday in the Casper stand-up, they covered a technical observation about duality in the naive interpretation of QM in the row calculus. Yesterday in the communications working group, we did some small live updates to the website. Thank you, Raphael, and discussed the current investment opportunities. And this morning in the members hangout, Jim showed a PR video of his dream boat. And then he started talking about using Smalltalk as a front end for Rolang. Then RChain member Aaron joined the call and had some questions about Rolang and Swee's language called Move. And that brings us to now.
Awesome. Thank you very much. Any questions for Daryl? Okay. Well, I do want to say that the board met this last week or yesterday, and most of the discussion was around some interest from a financial firm. I can give more details on that in the closed door session on Friday. So if you want to hear about that, we've also had some good engagement from members on that topic. So it's receiving a lot of good, solid attention, and we'll be able to give, I think, a fairly significant update on Friday. I don't think there was anything else worth mentioning, discussed at the board, and I think that's it. I think that's all we've got to cover for today. There's about 13 minutes left. Any questions, comments, concerns, considerations? This is your time as well as ours.
I can talk about my trip to Washington, D.C. for the Government Blockchain Association.
Fantastic, Steve. Yes, Mr. Henley goes to Washington.
Yes, indeed. So hello, everybody. So I'm a member of the Government Blockchain Association, and you can visit their website. It's gbaglobal.org if you want to check out who they are. They are a international organization consisting of government agencies, academia, and private sector individuals, not only in the United States, but in Europe, in Asia, all around the world. So they have different chapters representing these different locations. So this past week, I was in Washington, D.C., attending the Blockchain and Sustainable Economic Growth conference, which essentially was looking at blockchain and how it can address some of the sustainability issues that are pressing on society today. So we had various speakers and panelists talking about their solutions and what's going on in the world of blockchain. And we had several state and county representatives from Massachusetts, Rhode Island, and also from Florida, that they've expressed an interest in digitizing government services, similar to what Estonia has done. For Estonia, they have e-citizen, where a lot of the government services are now digitized. So a goal would be to for county, state, and county government services, digitize those, and where appropriate, put those onto a blockchain. So that's some of the forward thinking that's going on within the Government Blockchain Association. And one valuable resource that the GBA is creating is called the Blockchain Maturity Model. So at last count, when I visited Coin Market Cap, there was upwards towards 20,000 various blockchain projects. So, for a government agency or enterprise, it would be difficult to, how do you go about assessing, a particular blockchain project, what it can and cannot do, and what its strengths are, and what the blockchain maturity model is a resource to help government agencies, enterprises to do that assessment, create some type of standardization around the various elements of a blockchain. And in this, the BMM, there's actually 11 core requirements. So I have them listed here, starting with distribution all the way to synchronization. And within each requirement, there's 5 levels, going from the initial all the way up to level 5 of optimization. So I attended on a Friday a workshop, which was on the BMM, so getting familiar with this model and how RChain can do a self-assessment and start to work through this process of being evaluated. But yeah, I think this will be hopefully, it could be a valuable tool for enterprises and government agencies to as they want to bring on blockchain for their business or for government services, being able to do that blockchain evaluation. So that's essentially what the conference was about, and happy to answer any questions anyone might have. Great, thank you, everybody. Back to you, Greg.
Thanks very much. Yeah. I also, Ralph Benko was there. Ralph has been doing some work with the co-op. He's a lawyer who has a lot of connections on Capitol Hill, and he sent me a photograph of Carbon Meta's presentation that had RChain featured prominently there. So that was also very nice to see to see a discussion of RChain being used in a climate solution. So very, very much in alignment with our goals. Very, very excited about that as well. All right. So unless there's anything else, any last burning comments, I think we can close it here. Please stay safe. I know that there's another variant of COVID going around. A lot of my friends have caught it. So please do stay safe and take some time to enjoy the spring, and we'll see you on the other side.